My dad has this $20 Harbor Freight Sawzall, and somehow he lost the blade guard for it. I've always wanted to try to press form sheet metal using 3D printed forms. I haven't really ever seen that done before, and it seems like a fun project. So I'm gonna see, based just on photos I can find of what the blade guard looks online, design one, cut the sheet metal, and then hopefully design some forms that'll let me make a functional end for it. So let's see if we can do it. This is the best picture of the blade guard I could find, and it looks like it's made of 2 parts riveted together. The blade guard is where all the hard features are. It has bends all the way around the perimeter, which isn't too bad, but they're right next to a hole, and that's something you really try to avoid in sheet metal because it's very difficult to get the bend made without distorting the hole. And then inside the hole, you probably can't see in this photo, it's formed with a radius all the way around the edge, and that you can't do with normal bending. That is some kind of punching or forming operation. And so I took some dimensions off the Sawzall, came up with this, and just for reference, this is a cross section of what the form feature looks like. And this is the part I'm most concerned about for pressing with 3D printed parts, because this is a lot higher pressures and forces than you would get for a simple bend, because you're actually compressing and stretching the steel a lot more. And so I'm worried that I'll either just shatter the die or smush it or something like that. I'll make some drawings and we'll go cut them out. I'll be cutting the parts out using a CNC plasma cutter. I'll be cutting them out of 16-18 gauge steel. And if you haven't seen a plasma cutter before, it actually cuts conductive metals using electricity. And the way it works is it creates a jet of ionized gas. In the case of mine, it's air. And this allows electricity to flow from the nozzle to the workpiece, and the electricity basically forms an arc which delivers an enormous amount of heat to a very small area, which just cuts through the metal. And they're super fast and super handy for work like this. I 3D printed this die or form, or I don't know exactly what you would call it, but it's basically the space below the sheet metal part that I want after it's been folded. And it has a registration feature on top so that I can take the sheet metal that I just plasma cut and it'll hold it in the right spot. And then when I bend it, it will wrap around this block and have the right bends in the right spots with the right angles. Now to bend it around this form, I need another form or die which goes on top of it, which has basically the space of the air or whatever above the part. And so that's this. So it has a cavity in it which has the shape of the space above the part, and then I'll put this in the press and shove it down really hard, and hopefully it'll bend this thing to the right shape. Now there's actually still a problem. If I just try to set this on top and press it, it's not going to be in the right spot. And so I made this extra little frame. So this is a pocket which I can put the lower form into, and it'll hold it in the right spot. I can put 2 precision rods in. This upper form has bushings that go around those rods, and this will locate it correctly in space. We'll take it over to the press and give it a smash and see how it does. All right, looks like the form is mostly undamaged, but it is in there tight. This is okay. There's actually damage or poor bending at the top. This is actually to be expected. Generally speaking, when you're making sheet metal parts, you do not want holes near bends because you have this problem that it distorts the part when you try to bend it. I think I can actually change the design of this to mitigate that by pressing this before I start folding it to lock it in place. This part was pretty difficult to get out of the upper die, and the reason for that is it's not actually square. The flanges are bent out a little bit. You might be able to see it if I put a square against it. And that basically wedged it into the mold when I was done. And the reason for this is it's a material property of the metal. The metal has some springiness to it before it will actually bend. And so I'm bending it to a 90, but then it pops out a little bit. If I want an actual 90, I have to bend it beyond 90, which I can't do just by coming straight down with a press because there's no clearance to get under it. So one of the neat things about 3D printed tooling is that it's a lot easier than with machine tooling to get some kind of action that can fold the flange under and then come back out, because I can print whatever geometry I want without having to do really more work other than a little bit of design. So here's a quick demo of the spring back that I was talking about. I have a vise, which is acting as half the form. I have some aluminum, which I'm forming, and then I have the top of the form, which is just a piece of aluminum bar. Just like the steel, it's wedged in, and you see it springs out. I just can't get a 90-degree bend with anything that has elasticity. All right, top die V2. And this one's pretty similar to the previous one, and the main difference is it has these two big holes in the top, which allow some pretty stiff springs to pass through the die. And the way that this will work is I will epoxy this little plate that I cut on top, and then the springs will go into the holes, and then I have this other plate which I need to decide how I'm going to attach it. I'll probably just weld it maybe, although I'm a bit afraid of annealing the springs. I'll probably just glue it. It'll be on these springs, and so when this comes down to form the part, I first have to compress these springs, which should firmly clamp the part and prevent that top from bowing up and giving me this very undesirable shape that I have. Very nice. Very, very nice. Nice clean bends. There's no doming or flatness on the top. Significantly improved. 3D printing tooling seems to work pretty well for making bends in sheet metal, but what I really want to do is make a formed feature. And so a lot of stamped parts, and if you looking at the photo for this part online, there's actually a formed lip around the inside of the part, and I want to try to form that. So I made another set of dies. This one actually has a opening where I will try to press the sheet metal into this hole, and it has a radius all the way around, and hopefully I can smash it in there and get a radius on the part. And I have a matching die which hopefully does the smashing. I don't have high hopes for this. I've seen dies before that do this, and when I've visited factories, and this doesn't seem quite right. It's definitely going to put some serious strain on the part. And so I'm going to actually start with a much thinner piece of galvanized steel. Excuse the really terrible cut quality. I haven't actually cut this before and don't have the settings dialed, but the slot in the middle is generally right. So this will set on top of this die, and we will smash this die into it. Doesn't seem quite right. Well, it would appear I installed my die wrong. So I made a giant error when I was going to press that. I installed the upper die backwards. So the die smashed into basically a wall, which the press completely demolished. Now the ease with which the press demolished it was a bit shocking, but also probably indicates that this material just isn't going to work. But I kept on smashing just to see if I got anything out of it. And I was like, sweet, on there. Let's get it off. Kind of. There's a bit of a formed edge in there. I'll have to reprint this, but I'm gonna try it again with some slightly thicker material because I don't care if I destroy this jig. So I've got some 18 gauge steel here. Let's go throw this in the press. All right, I just pressed that off camera because it's the same thing that I've done every time. So it actually looks like it formed most of the feature. It's pretty decent looking actually. It doesn't look like, other than the damage I did to the form with the press, it doesn't look like I actually damaged the form either. The bottom form is looking good as well. Wow. So I was looking at this part and I just realized I made a big error in the design of the form. So this form is only designed to basically put a radius on the slot that was already formed in the part. The slot will get a little bit wider because it has to form a radius, but it doesn't actually really widen it, and there's not enough material to stand it up straight, which is what I was going for. And it's because I just designed it wrong. This needs to first form the slot to be wider and then radius it. And so I need to make a tool that does that. Unfortunately, I don't have a 3D printer available right now, so I'm going to machine these, just see if it works, because I'm really curious to see if this will work. All right, we've got some stock in the mill. Gonna make it out of some aluminum bar stock, and hopefully this works. We have ourselves a die. Now, given that my original goal was to see if I could form sheet metal with 3D printed parts, this is cheating just a little bit. It's only half cheating because I'm still going to use a 3D printed half of the die. I just really want to try this, and this only took maybe 15 minutes to machine on the CNC, so it gives me that great sense of instant gratification that I'm seeking. Back in the press, we have the aluminum die in there. Everything's oiled up. So let's see if we can get some forming done. Oh. There goes the die. Although I think I might have gotten it formed before I exploded the die. This is a lot more carnage than I thought. So it looks like what happened is that I exploded the inner die, which exploded the outer die. So that die is toast. But this looks pretty nice. So would you look at this? Looks like I formed the feature before I exploded the die. I'm pretty sure I could do this on a 3D printed die. This die, the machined one, is loaded totally under compression, and so I don't see why it wouldn't survive the process. This one is loaded under tension. It's trying to be pulled apart by the sheet metal. That's probably what broke it apart. I could probably also survive if I just made this a bit thicker, or made it out of maybe a different resin with a higher yield point. So yeah, half success, half cheating. Just need to bend this into the final part, and I will call it a success. Reviewing the footage of the press, I think I understand why the tool broke, and I don't think it was due to the pressures and forces of forming, at least not the outer tool. The inner tool might have broken from the pressures, it kind of looks like it did, but the outer tool, when I was pressing it, it was actually cocked a little bit. And I think what was happening was that the bushing was camming onto the guide rod. And what camming will do is, it doesn't matter how hard I push with the press here, it will not slide. I can literally push with infinite force, it won't slide. The harder I push, friction is generated here that's more than the force, and that's it. So I think the press just snapped the tool in half. All right, so to finish off this formed piece, I took the original form and milled a pocket in it to make space for this, because I don't have a form that will hold this. The normal intent would be to first do the bending, then form this feature. but since I destroyed my form tool, I have to do it out of order. All right, due to the complete and total failure of the 1 minute epoxy, I've reconfigured the spring press a different way. Well, let's take her apart. See how we did. Oh, yeah, awesome. So we have a nearly totally flat top with a formed in feature. Nice bends. Nice. I am really happy with this part. The second part of this blade guard isn't very special. I can bend it normally, so I'm going to just bend it in the vice brake. We've got our two pieces. Just got to build them up now. So, there we have it. A 3D printed form bent, complex formed, and it looks great. The only thing I really want to do after I make sure that it actually fits the saw is to powder coat it. So overall, this process is quite promising. I think with the few tweaks, I could have some tooling that I'm printing that would allow me to make maybe 100 or more of these. And that's really the point of making the tooling. It really doesn't make sense to make the tooling to make a single one. If I only wanted a single one, I probably just would have actually machined it out of a piece of aluminum or something rather than trying to make it out of sheet metal. It's a pretty cool concept, and the things I would like to do in the future is fully 3D print the molds, so 3D print this forming operation here. All right, scratch that. I really didn't feel right saying this was a victory when I only half won. That actually sounds a whole lot more like first place loser to me. So I printed another set of forms, and I actually noticed a small interference when I was looking at the CAD between the interface of this form and the face of this form, and it would tend to split this form apart like a log splitter. And I think that might be what actually split the form apart before, so fingers crossed. I hope it'll work this time. I got everything else fixed up, and very presumptuously, 3 blanks ready to be pressed. So let's give it a try. We're starting off with the side bends, with doing things in the correct order this time. Well, so much for the epoxy. Yikes. But I realized that my super optimized, even lower bottom form was bottoming out the whole press assembly before I could get a full stroke. So I've put a previous form underneath, and we're gonna finish off this press. All right, that operation looks pretty good. So I'm gonna go for the inner form now. This is the setup that was intended, and it's pretty cool because you can have the part, you can leave the part as it is and just replace the top die. I have my new mini die inserted in here, and I'm going to give it a press. Sounds like I exploded the die. Bummer. So it was definitely presumptuous to cut three blanks. Here's the broken apart form. It's pretty cool how perfectly symmetric it broke. Here's the part. It just about worked. The front edge is slightly incompletely formed, but I'll call this almost a win. I would use this part. It's basically good. And I think this is a good stopping point. You certainly can 3D print forms and form relatively thick gauge sheet metal with it, at least once. I think you could do it more than once with maybe a bit more section, a resin with a higher UTS, or maybe modifying the feature a little bit or doing it in 2 passes so it's less aggressive. This tool was definitely very aggressive. But overall, I'm pretty happy with the results, and I feel like I got a good feel for what you can do. I'd really like to make a form that has some kind of action on it, either to get 90-degree walls or some other complicated feature. Hopefully you enjoyed this. If you didn't, I have no idea why you're still watching this. And I'm out of here. Thanks.